Si quieren asistir a este video en español, clic en el link en la descripción.
Hello everyone, I'm Thalles from Plugin. I hope you guys are doing well. And today we're bringing you a little bit about Advanced Driver Assistance Systems, aka ADAS. Today is more sort of an introduction of how the ADAS started, what were the big concerns that made the industries to start to develop these types of safety features. We're going to talk about some of the ADAS systems that are running on the car nowadays, and we're going to have a little talk about how we are expecting that ADAS will work in the future. So, my name is Thalles Yuri, as I said, and my partner Fernando. He is gonna make this whole content in Spanish. So, if you guys want, please check his channel. The link will be in the description. And let's start it. So, today we're bringing you guys more of an overview about ADAS. So, first of all, let's talk about what ADAS actually is. And ADAS is just a conjunction of systems that are used to enhance the safety and give the driver more comfort when they're driving on the road. So let's say that these were developed to avoid, and the intention is in the future, finish with all accidents and also give the driver less things to worry about when they're driving, and maybe even improve the driving experience. Okay, so everything starts with a concern. So what were the concerns that started to make the manufacturers worry about safety in the first place? So transit or traffics in general are places where we can have a lot of accidents, and which bring more concern than accidents are death. And unfortunately, there are many people who unfortunately lost their lives while driving. And thinking about this, they started to try to look for a way to improving it, because as you guys can see in this graphic that I brought to you, um, not only, of course, first of all, the green lights are the amount of people who passed away or who lost their lives while driving. And as you guys can see, the amount of death are substantially big. But the blue line of this graphic, I'm sorry, are the amount of people who lost their lives during in a car accident, let's say, per 100,000 population, for 100,000 people. So, um, although this green light is increasing over time, the blue light is decreasing because it's a more accurate data, because it's telling the amount of accidents or the amount of people who lost their lives per an amount of people, and not the total amount, because as we know, the population of United States increased over time, so we couldn't have like a very accurate data if we didn't do this proportion between the amount of people who lost their lives and the total population. So I have some data that I brought to you guys from NHTSA, National Highway Traffic Safety Administration, that tells that in 1937 we had 30.8 deaths per per 100,000 population. In 2022, this amount decreased to 13.8 per 100,000 population. So we have a decreasement of 55% of deaths. And this could be one of the reasons could be the ADAS or the safety systems that were developed by the cars, okay? Another data that I want to bring to you guys is that in 1913, 33.38 people died for every 1,000 vehicles we have on the way on the traffic or we have on the road, let's say. In 2022, this amount decreased from 33.38 to 1.5 per 10,000 vehicles on the road. So we had a 95% of improvement. And we have more. In 1923, the first year, that was the first year where they could have records of the miles that all cars were driving yearly. We had 18.65 deaths per 100 million miles driven. So in 1923, the first year that we could have records of how many miles the cars were driven in total, we had a total of 18.65 deaths for every 100 million miles driven. And in 2022, we had, where's the value? Oh, 1.33 deaths for the same amount, 100 million miles driven. So we had an improvement of 93%. So we could improve, not we, but the manufacturers industry using ADAS could improve a lot these values. But I'm gonna bring you guys another data. From 2019 to 2022, the vehicle death rate increased by 6.4%. The mileage death increased 10.8%, while the population death rate increased 16%, which means that we are still have a lot of things going on. It could be other factors besides the traffic itself that could help changing these numbers, but the biggest concern is about the deaths and accidents we have on the road. So this is why ADAS is a land, let's say a land because it's a lot of things to study and incorporate on it. This will keep being developed. This will keep being developed over and over and over until we try to get these values to almost zero. So we have this big concern: accidents and death. How can we solve this problem, or how were the manufacturers thinks about solving this problem? The first thing that came to their minds, or how they started to work on this, is by developing various safety systems. Okay, so first of all, they were thinking, oh, we're having a lot of accidents, we're having a lot of deaths on the road. Let's make safety systems that can help to decrease this amount of deaths and accidents. Okay, so they were concerned about two things. First of all, how could people escape from these accidents with less injuries? And second, how can they prevent these accidents for even happening in the first place? So by that, they started to also think that safety was something that the market was looking for. The customer were not looking only for gas, for technology systems, but also they were searching for cars that were more safe because death in the road is a concern. Okay? So, what are these safety systems? We have two types: passive and active. The passive are the ones who are responsible to make the injuries get less worse, or in other words, they were developed for the after crash. These are the seat belts, the airbags, the padding on the dashboard. Some dashboards they have some sort of a padding around that makes it more soft, and the other ones are the active systems. The active systems are the ones who prevent the crash from even happen. These are the ones that we are talking more about in our channel, which are the ADAS systems. And we have as an example lane keep assist, adaptive cruise control, and also automatic braking. As I brought this whole history, now we are in the main point of our video. What are advanced driver assistance systems, ADAS? So these are a set of technologies that were developed, first of all, for safety, to bring more comfortable or more comfort while you are driving your vehicle, and also to enhance your driving experience. So you will have safety, you will be more comfort while you're driving because you won't gonna have to be aware of many things that could happen while you are on the road, and this will be enhanced because you will have a better experience driving. Okay? So, how was the evolution of ADAS working? So, how we got all the way from the starting to this point that we are right now. So, back in the 50s and 60s, the earliest forms of ADAS, were the seat belts and the padded boards. These, as I said before, were developed to get the injuries from the accidents less worse. More when we advance to the 70s and 80s, we have more safety systems. One is going to be the anti-lock braking systems, the ABS, which enhance the braking and to having a more fast response. And the other one is the traction control systems that will control the traction of your car while you're driving on different types of roads. In the 90s and in the 2000s, when we started to incorporate a little bit more advanced technologies like electronic stability control, so we don't have more a traction stability control, we have more like an electronic one. So we are bringing more electric parts to the vehicles. We have parking assistance, that was the first uh, type of sound sensors that we had, and the cruise control that were developed to keep a car at a certain speed while you're driving on the highway and makes the driving experience less. Let's say it makes the driving experience better because you don't need to like keep your foot on the accelerator for a big amount of time. Then in the 2010s, ADAS started to become more spread through the manufacturers, and we start to have more of a warnings while you are driving the vehicle. So we have the lane departure warning that will give you um, a vision sign, a sound sign of when you go off the lanes. We have the forward collision warning that will detect an object ahead and will alert you for so you can brake your car and not having an accident. Maybe you are distracted or something and there's a object right in front of you. The car will tell you that, and then you're gonna like enhance the brakes. And then we have the automatic emergency braking that are the ones that startled us a lot. That like when it detects an object right in front of you, the cars will brake by itself. And then on the present, we are having more of a control of the cars while you are driving. So we have the lane keep assistance, which is different from the lane departure, because before we had a warning, and now we are having more of a keep assistance. So when you go off the lanes, the car will enhance the steering wheel and put you back in the middle of the lanes. We have the blind spot monitoring, which are the ones that when you try to check your blind spot, maybe you cannot see a car that is coming on your side, so this will alert you. And we have the traffic sign recognitions that we're gonna talk more in depth later on, okay? Now we are gonna talk more in depth of each type of these systems that we have, that all together we form the ADAS, okay? So first of all, we're going to talk about collision avoidance systems. These are basically to prevent collision by detecting obstacles or vehicles in the path. These are used to try to prevent the accident for even happen, or try to at least mitigate the accident. So for this we have the automatic emergency braking, which will activate the brake whenever they see an alert of crashing ahead of the vehicle. So let's say that they detect that the car in front of you is even stopped or on a speed that is less than yours. It will automatically activate the brake and make your car brakes by itself, and it's a very strong brake. And then we have the forward collision warning that will detect the car in front of you and will give you an alert before the crash happens. And this can give you back the attention to the road and make you brake the car right in time. Okay? Another feature we have is the adaptive cruise control, which will maintain your vehicle on a set speed, but also will detect the speed and the distance on the car ahead of you and make your car be on the same speed in order to avoid the accident way longer before it even happens. This one is the lane departure warning or lane keep assist. So the lane departure warning will warn you, as the name says, when you go off the lanes. And by that I mean when you're not intended to go off the lane, because if the car detects that you turn the sign, let's say to the right side on, it will not activate. It will activate when you are not intended to go off the lane and you go either way. Okay? The other one that we have is the lane keep assist that will steering the wheel back every time that you go off the lane. Okay? The next one is the blind spot monitoring The blind spot monitoring will detect, it will have a sensor that will detect your blind spot on each side, and whenever you are intended to change the lanes, and it will detect also, first of all, even if you're like straight on the road, it will show you that is a car on your blind spot, even on the right side or on the left side. But then when you turn the sign, let's say that you want to go to the right side, even more than just the light, it will warn you that no, you want to change the lane, but there is a car on your blind spot. So it will not say that, but it will make a sound and make you not do this maneuver while the car is in your blind spot. Actually, it will not make you not doing, but it will alert you for that, okay? The next one is not while you're driving on the freeway, for example, but it's an assistance when you are parking. So we have the rear camera, we have the sensors that are located on the bumper of your vehicle that will give you a sign as closer as you are from an obstacle whenever you are doing the reverse, you're going in front. When you are parking, it will help you to make the whole maneuver of parking your vehicle, okay? And then we have the traffic sign recognitions that use the cameras that are located on your vehicle, usually the cameras that are on your windshield, to recognize the signs that you have on the road. So let's say that you have a speed limit sign, it will check this speed limit and maybe communicate with your adaptive cruise control and put your car at this speed, or maybe it will detect a stop sign and alerts you that is a stop right in front of you, or even an yield sign, okay? So how ADAS works? ADAS are is a component that contains sensors, control systems, and actuators that communicate within each other. The sensors are the systems that are responsible to gather all the informations for the vehicle. So we have the cameras. The cameras are responsible to give the visual informations for the vehicle. So it will give the data for the traffic signs, for example, a pedestrian that is right in front of the vehicle, the lanes. These are examples that the camera can bring, the data that the camera can bring to the vehicle. The other sensor is the radar, and the radar are not more, not less than waves, the radar waves that are able to detect the ranging. So it will detect the distance from the vehicle ahead, for example, and also the speed that this vehicle ahead is traveling on. Okay? And then we have lidar that are uh, laser pulses that are able to detect not only the distance from other objects, but it will give you a 3D, very specific view of the environment around the vehicle. So it's a more in depth and more detailed information that the vehicle can gather on this its surroundings, okay? And then we have the control systems. The control systems will process the data that were gathered from the sensors. And what it's going to do is that we will have the electronic control units that will have this data and run algorithms. And these algorithms are going to be responsible to give the better response for this vehicle, okay? And then we have the actuators. The actuators will execute an action based on the data that were received from the sensor and the algorithms that were run from the ECU. So we have the brake actuators. So whenever something happens, it will activate the brakes. We have the steering actuators that will activate your steering wheel depending on the situation. And we have the throttle. I don't know if my saying is right, but the throttle, maybe it's throttle actuators that will activate basically the accelerator whenever it it feels that this is the situation to activate. Okay, bringing everything together, we have these questions: how these components works. So first of all, we have the detection. I'm gonna give you guys an example of an adaptive cruise control. Let's say that you are driving on the freeway and you activate your adaptive cruise control and you set your cruise control for a speed of 70 miles per hour on the freeway. Let's say that. And then your radar is constantly trying to detect vehicles ahead. Let's say that at some point there is a car right in front of you from certain distance that is driving on a 55 miles per hour. So first of all, it's gonna what is gonna happen is that the detection. The radar will send the radio waves and detect the vehicle ahead. The next step, it will process the data that the radar gathered for the vehicle. And you will get, oh, this car right in front of you is in a certain distance and on a certain speed. What is the decision we're gonna make with this information? Oh, let's brake this car in order to keep the distance from the car ahead farther and keep the vehicle on a safety spot. And this will keep happening and happening and happening, because let's say that the vehicle in front of you had to make a break and go to, let's say, 35 miles per hour. The radar will detect this, will give the information to the ECU. The ECU will run their algorithms, and then the algorithms will decide, oh, let's brake the car, let's activate the brake and make this car now goes 35 miles per hour. And then let's say that the car in front of you accelerate the car and goes to 70 miles per hour. It will see that the car is getting from a distance farther and farther from you, and it's gonna detect that this car is increasing their speed. It will detect this, send to the ECU. The ECU will run their algorithms, and it will activate the accelerator in order to get back to 70 miles per hour. And this is going to be a feedback loop that's going to keep running while you are driving your vehicle. So now let's talk briefly about the benefits of ADAS. First of all, the first benefit you have is increased safety and reduced accidents. That's what, in the first place, ADAS was intended to do when they were first created. So now we are having way less accidents due to ADAS, and the driving experience is less stressful, let's say. Other benefits is that we have an enhanced driving comfort and more convenience. So now it's way more convenient to drive, let's say, because now you know that if a car is on your blind spot and you cannot see, your car will tell you about it. And the last benefit, there are more benefits, I just brought the more important ones, is the potential for improved traffic flow and reduced congestion. And this is a really good benefit, guys, because we know how long time we lose every single day on the traffic. So if we have a technology that are making this better, this is a great piece of technology. So now let's talk about the future. The future of ADAS is very exciting because, as I'm gonna tell you guys now, these are a lot of technologies for being developed, and I'm just bringing you guys a little bit of all of the studies that are happening right now in order to make the drive more safe. So first of all, we will might have a integration V2V, and an integration V2V will be vehicle to vehicle, and V2I, vehicle to infrastructure communication system. So the cars will communicate within each other. This is so exciting. They're gonna communicate within each other, and they're gonna know in real time what is gonna be the position of the other vehicle, the distance, the speed, all of information that now the car have from its own sensors. It will be data driven and communications between one car to another. This is something. And also, not only that, the car will have real time information from the traffic ahead. Let's say that it has an accident 10 miles away, the car will know, and you will know beforehand that is a traffic over there. You won't gonna need even your GPS anymore. You will be having a communication, and your car maybe will alert you of this. Or let's say that you will be at some point that when the light turns green, your car will start to accelerate by itself. So this is a lot of good features that we are expecting for the future. The autonomous driving capabilities is also evolving with the evolution of computer science, the evolution of artificial intelligence, also the hardwares, let's say the sensors. We will have even more accuracy of the surroundings of this vehicle. So we are moving step by step closer to the fully autonomous driving. And we already have the highway pilot, for example, that makes the driving on the freeway, on the highway, let's say, fully automatic. And this is going to be something that is going to always be evolving with more accurate sensors, with more memory, with more communications until the point of autonomous drive fully. Okay? With all of that evolution, we will have regulatory changes and industry standards. Because, first of all, with all different manufacturers and branches making different types of equipment, the performance will have to at some point have some standards, and they will have an agreement and say, no, from this point we will be we will accept it, and before this point we will not accept it. So we will have standards for any type of ADAS systems. Also, the testing procedures, I think, is going to be more the same for every type of manufacturing in order to have the same type of safety technology working on different brands of cars. And also, it will bring more types of certifications for different ADAS equipments. So the blind spot will have to have some certificates that will show the customer, the final consumer, that this is safe and this was approved by the standards. Okay? That's it, guys. That's all that I have to bring to you. Thank you so much for watching. If you guys have any question about all of this content that was brought to you, please leave a comment and we will be more than happy to answer and assist you with that. Also, if you guys have any type of tip or anything that maybe we said wrong or maybe we didn't brought the right data, please comment below. We will be more than happy to check it for you guys, okay? As always, thank you so much for watching this video. Again, if you guys want to watch this content in Spanish, my partner Fernando made this full content in Spanish. Thank you guys so much for watching. Make sure to subscribe to our channel, leave a like on the like button, and I'll see you guys soon. Stay plugged in. Bye bye.